you very much. So who is already familiar with propensity scores? Okay, so good. A bit like the last talk, my assumption is that you don't know anything about propensity scores. So if you don't, it's good. If you do, you maybe learn something, but maybe learn less than the other people. Okay, so we are going to talk about the theory behind propensity scores and appreciate how they can be used to adjust for confounding. So we'll talk about why we would use them, how we would use them in practice, and how they compare with multivariable methods of confounding adjustment. So again, to recap, confounding by indication. It's all about differences between people and how those differences are associated with the reason why we give some people one treatment and other people either no treatment or different treatments. Okay, so here again we have a general practitioner and we have two patients. I don't know if you can see these patients very well. Can you see them very well? Can you see that they're different to each other? Good. Okay, so at the top here, I'll be generous. We've got somebody who's a little bit overweight and he enjoys a lot of junk food. He probably smokes a lot and he drinks a lot, and I don't think he does much exercise. She looks quite different to me. I don't think she has a lot of junk food and she looks like she's quite active. Okay, so let's say they've got the same GP, this lady here. They're the same age, they've got the same GP, but if they go see their GP on the same day, I hope that the GP is going to give him a statin. I think she's only gone to the GP because she's going on a yoga retreat and she needs a vaccine for whichever country she's going to. She doesn't need a statin. So they're quite different people. Now, normally when we do a study, if we want to compare people given one treatment with people given no treatment or a different treatment, we'll usually use a multivariable method to adjust for confounding. The problem is, within our big populations in an electronic health record database, it's very hard to tell if our exposed population tends to look a bit more like him and our unexposed population tend to look a bit like her. On an individual level, we would all know not to compare him with her and assign differences in outcomes to his statin. Yeah? If we wanted to look at the effect of statins, we just would not compare him with her. But what if our statin group are just a bit more like him and our no statin group are a bit more like her? I think it would be difficult to know just by looking at the data that this is the position we're in. So I think confounding by indication is probably the biggest of all the problems we have in pharmacoepidemiology. Okay. I think that propensity scores are potentially one solution to this problem. So if we're going to make comparisons between people, they need to be fair comparisons. Patients who are given drugs are different to people who are not given drugs. We need to try and account for those ways as best we can and then do our analysis. So options for overcoming confounding of any kind are randomization, as we know, multivariable regression. We could use a case-only approach, as we talked about earlier, or we could potentially use propensity scores. There are other methods too, but these are four of the most common. Okay. So you know that in multivariable regression, we construct a single statistical model and we model the relationship between the exposure and the outcome independently of all of the other confounding variables. But they're all included in the model, and everybody in the study population gets included in the analysis. Okay? Sounds fairly straightforward. And you all know that the output that you may get would look something like this. Is this familiar to people? You've all done this kind of thing before where you've got, so the first line here, we've got the hazard ratio for some exposure, I've called it exposed, with some outcome, and the hazard ratio is 0.87 and the confidence intervals are all below 1. But at the same time in my output, I get other hazard ratios associated with the other variables in the model. So here I've got things like diabetes, heart failure, and it tells me what's the independent association of those variables with the same outcome. Yeah, also familiar. Now, multivariable regression is great, but I think it also has some problems. I think it's potentially a sort of a black box approach. What I mean by this is that if our groups are fundamentally different from each other, so if our exposed group looks mostly like the obese guy who's eating burgers, and our unexposed group looks mostly like the woman who's doing yoga, we'll still run the regression and we'll get an answer, but we won't realise that there was this problem in the data.